All right, looking at the Unit 7 review. So the first one is x plus 6 in the parentheses, and it wants to know how has the following moved. So inside affects your inputs. Your inputs are your x values left and right. You change your thinking inside. So this is actually left 6. The next one, we're comparing the parent function to this negative 3x squared. So the negative tells us it's a reflection over the x-axis. And the 3 indicates a vertical shift, a vertical stretch with a scale factor 3. The next one says it wants us to translate the function 3 to the x 5 units to the left. So we have, because we're moving to the left, it's going to affect the x values, and the x values are inside the parentheses. So we have 3 to the x minus negative 5. So remember, when you minus a negative, you're actually adding. So this would be 3 to the x plus 5. So the next one says 3 to the x 5 units down. Down is an output. It affects the y, so it's outside the parentheses, and we don't change outside. So we have 3 to the x minus 5. So to make the equation for the graph provided in vertex form, you have to know the vertex. So our vertex is here at 4, 2. The a value, because it goes to the right one and up 1, and to the left one and up 1, your a value is 1. So when we plug this into the vertex form, we have y equals a is 1, so we don't have to write it. X minus 4 squared and a positive 2. So to make the equation for this graph, the y-intercept is always 0, 1 on the parent function. So this y-intercept that was right here is actually now right there. So it's gone up 2 and to the right 1. So if we look at the asymptote has moved up 2 as well. So it corresponds with that. So we know it's going to have a plus 2 at the end. Because it's right 1, we have x minus 1 in the exponent, and it's exponential growth, so we're going to have a base of 2. So growth or decay, this one is actually growth because the base is greater than 1. So the rate of change on this one, remember that 1 is always there just straight from the formula. So in this one, the rate of growth is indicated by that 0.6, 0.6, which as a percent is 60%. So it's growing by 60%. The next one, we have f of x equals 9, x minus 9 shifted up 4 and 7 to the left. So if we're going to make it go up 4, our original, remember, is x. We have a minus 9 affecting the outputs. So to go to the left 7 units, it's a negative 7, and then up 4 is an output value. So to write this neater, when you subtract a negative, you're actually adding. So we have x plus 7, and then negative 9 plus 4 is negative 5. So this one asks, what is the y-intercept? On your paper, it's not very clear, so pay close attention here. So we have a y-intercept of negative 12. So 0, negative 12. The vertex for this one is down here at negative 2, negative 16. So if we're going to write this in vertex form, then multiply out to put it in standard form, we also have to know A. So if you look left and right of the vertex, to the left and to the right, it's up one block. So that means your A is 1. So now that we have everything we need to know, we can plug it into vertex form. Y equals A is 1, X minus H, which is your X value from your vertex, squared plus K. So to put it in a cleaner look, X plus 2 squared minus 16. So to put it in standard form, we have to do the box thing. So we're going to take care of this chunk first by doing the box thing. So we have X plus 2, X plus 2. So X times X is X squared. 2 times X is 2X. 2 times X is 2X. And 2 times 2 is 4. So that chunk of that equation becomes Y equals X squared plus 4X, from combining your like terms, 2X and 2X, and plus 4, and then don't forget to bring down that minus 16. So when you combine like terms, that's those two there on the end, we have Y equals X squared plus 4X minus 12, and that's your standard form. So the next one says, if the roots or x-intercepts of a quadratic function, parabola, are x equals -3 and x equals +3, what is the equation for the axis of symmetry? The axis of symmetry is always in the middle. So in the middle between -3 and +3 is 0. So your axis of symmetry is at 0 because it's in the middle of -3 and +3. So the vertex form for this equation, our vertex is at -3, 1. Our A value, as we go left and right, we go down 1 to get back to the line. So your A value is -1. So when we write it, we have Y equals -1 X minus H squared plus K. So to clean it up a little bit, we have Y equals negative X plus 3 squared plus 1. The next one's asking for the vertex. So to find the vertex, your H value, your X value are the same. So we have X equals -b over 2a. So your A value is 1, is the implied one in front. The B value is the 10. So we do negative B is 10 over 2 times A is the implied one, which means the X value is -10 divided by 2, -5. So now we take that and we plug it back into the original equation in order to find the Y value. So your X values are -5. And we end up with -34. So the vertex for the equation is -5, -34. Your A value is 1, and we also need that for our vertex form. So when we write vertex form, we're left with Y equals A is 1, X minus -5 would be a +5 squared minus 34. So our next page, it says write the equation in intercept form. So for intercept form, you have to know your two x-intercepts. We have one of them at 1 and the other one at 3. So when you write your equation in intercept form, you have x minus p, x minus q. So we have y equals x minus 1 times x minus 3. Remember, the subtraction comes from the formula. So then it says multiply it out to get it in standard form. So if we do the box thing, we have x minus 1, x minus 3, x times x is x squared, negative 1 times x is negative x, x times negative 3 is negative 3x, and negative 1 times negative 3 is a positive 3. So when we rewrite this in standard form, we have x squared, combine like terms, negative 3x minus 1x is negative 4x, and plus 3. So this says write the function of a graph, write a function that represents a quadratic after it's been translated up 3 units. So there's your k value, and reflected over the x-axis and vertically stretched 4 units. So because it's a quadratic, we know we're going to have an exponent of 2. Reflected over the x-axis means it's negative. The a value is negative, and vertically stretched 4 units. So your a is negative 4. So we have y equals, your a is negative 4, x squared, and a positive 3. Because it didn't move left or right at all, we don't need any parentheses. So the next one is an exponential decay. So I know I'm going to have half with an x in the exponent. It says an asymptote of negative 3. So k equals negative 3. And a shift 2 units left. So that would be in the exponent with x. And it's a negative 2. Your h equals negative 2. So when we write it, we have half to the x minus h. So x minus h, which is negative 2, and then plus k, which is minus 3. So if we wanted to write this a little bit prettier, we have y equals half to the x plus 2 minus 3. So the next one is a line. So linear functions do not have anything in the exponent. Exponential has an x in the exponent, quadratic has a 2. So we're going to be dealing with a line that has been horizontally stretched by a scale factor 1/4. So a is 1/4, reflected about the x-axis, so that 1/4 is negative, shifted left 2, so h equals negative 2, and then down 7, so k equals negative 7. So when we plug this into our formula, we have x minus h plus k, and our a value that I forgot to put up front is negative 1/4. So again, because it's got that minus and negative, we're going to write it a little bit prettier. So we have y equals negative 1/4 x plus 2 minus 7. So how do you know if a quadratic has a maximum or a minimum? So the two ways we look at quadratics is that it opens up or it opens down. So if it opens up, it has a minimum. If it opens down, just like in the picture, it has a maximum. So the next one says, for the following, convert it to standard form, then convert it to vertex form. So we have to do both parts. So the first thing I'm going to do is distribute this 3 to the x and the 2. So now I have 3x minus 6 as my first binomial, and x plus 4 as the second. So when you do your box thing, your area model, we have 3x minus 6 and x plus 4. 3x times x is 3x squared. negative 6 times x is negative 6x, 3x times 4 is 12x, and negative 6 times 4 is negative 24. So at this point, we've got it in standard form. That's y equals 3x squared, combine like terms, so plus 6x minus 24. So to go from standard form to vertex form, you have to find the vertex first. So this is A, this is B. So to find the x value, we do negative b, so negative 6 over 2 times a, which is 3. So negative 6 divided by 6 is negative 1. And when we plug that back into the standard form, it'll give us our y value. So we have 3x squared plus 6x minus 24. Again, x is negative 1. So we end up with negative 27. So now that we have our vertex is negative 1, negative 27, we have an a value, that's 3, that we pull from your standard form. So our vertex form is y equals a is 3, x minus h, which is that negative 1. So when you minus a negative, you're adding, squared, plus k. So remember the h value and the x value are the same thing. When you plug in and solve for y, you're solving for the k. All right, so the next one, it says change that into vertex form and state the vertex. Is the vertex a minimum or a maximum? So the first thing we have to do is find the x value by doing negative b. b is 24, negative 24, over 2a, and a is 3. So negative 24 times negative is a positive 24 over 6 gives us 4. So when you plug it back in, so we're plugging in that 4 for x, it gives us negative 43. So the vertex is at 4, negative 43. The a value, again, we need that for our formula. The a value is 3. So we write y equals a is 3 times x minus h is 4 squared plus k. So plus a negative is subtraction. All right, you deposit $650 into an account that has 8% interest compounded semi-annually. What is the money worth in 5 years and in 25 years? So we know that our principal is this $650. So we have $650. The 1 comes from the formula because you're earning interest. We're adding that 8%, which is written as 0.08. And it's compounded semi-annually, which means we have an in value of 2. And we want to know, what is it worth in 5 years? When you plug that in the calculator, you find out that in 5 years it would be worth $962.16. So when we're plugging it in for 25 years, it's the exact same formula. So it's still that 650, 1 plus 0.08 over 2 times 2, and then 25 years times 25. Plug that into the calculator and it'll give you $4,619.34. So then the next part is just labeling. So the initial amount is that 64. The ratio is what we're multiplying the 64 times. The rate is how you get from a 1 to a 0.87, and that's by subtracting 0.13. So that 0.13 is your rate. It's also 13%. So because that decimal is under 1, because we're subtracting, because the decimal that's your base is under 1, it is decay. And if we plug in a 13, we get 10.47. Last page. So we want to graph this quadratic. The y-intercept is always your c value. So it's 0, -1. To find your vertex, you do the a, b. So -b over 2 times a, which is 2. So we get -1 as the x coordinate for your vertex. Plug that back in. So we have 2x squared plus 4 times x minus 1. Our x value is -1. So when we plug that back in, we get -3. So that is the y value. Sorry about that. So -3 is the y value of your vertex. So because the a value is positive, the direction of this graph opens up, and the axis of symmetry is the same as the x coordinate in your vertex. So when we plug in everything we know, 0, -1 is your y-intercept. Your vertex is at -1, -3. We know that it's symmetric, so we have that dot there as well. And then we draw our parabola. So Amy owns a graphic design store. She purchases a new printer in her store. Her printer depreciates by a constant rate of 18% each year. There is the equation that we can use to model the function of the value of the printer after t years. So the $3,700 is her initial amount. So that is the price of the new printer. It says, what is the factor by which the printer depreciates each year? And that is 18%. Amy also considered purchasing a printer that costs $4,000 that depreciates by 25% each year. So it wants to know which one will have more value in 5 years. So if we figure it up for the original printer, this printer called V, we know that we're going to have, after 5 years, plugging a 5 in for T, in 5 years, printer V will be worth $1,371.74, roughly. So with this new printer, we'll call it N for new. There's a $4,000 is how much it cost. It's depreciating by 25% each year, and we want to know in 5 years. Plug it into your calculator, and that new printer would only be worth $949.22 roughly. So the one that has more value is printer V, the original one, the first one. So Amy wants to replace the original printer after 6 years. What is the cost of her printer after 6 years? So we go back to that other equation and plug in a 6 for X, and we find out that at 6 years, the original printer, printer V, is worth $1,124.82. So if she wanted to make a $200 profit, she would have to sell it for $1,324.82. So Joey and Jane were working on transformations together in Miss Jones's class. Each of them came up with a different answer when given the transformation problem. Determine if either student is correct. Also determine the aspects of each student's answers that are correct or incorrect. So we know that it is going to be vertically stretched by a scale factor 2 and reflex. That tells us that A equals -2. It's going to be a shift right 5. So we know that in our parentheses, we're going to have an x minus 5 and up 6. That means at the end, we're going to have a plus 6. So we know that neither of them are correct for the first one. And also, I forgot, it's an exponential growth. So it's going to be 2 to the x or 3 to the x. So Joey's answer, he has a scale factor of -3. That's not correct. He got the negative correct, but not the 3. His x minus 5 in the exponent was correct, and his plus 6 was correct. To have that half as the base is also correct because that represents the exponential growth. But Joey is incorrect about his A value. So A equals -2, not -3. So what was he correct about? The x minus 5 and the plus 6 at the end. So the k equals +6 he was correct about. So then we have Jane. Jane did a 1/2 as her A value. That's not correct. A equals -2. She got the negative correct, but the half should have been a 2. So in her exponent, she has x plus 5. That is not correct. So she has x plus 5 instead of x minus 5. All right, but she did get the plus 6 at the end correct. So that k equals 6, she got correct. So neither of them were perfectly correct. The last one, a super deadly strain of bacteria is causing the human population to decrease by 12% each year. There are currently 1,116,654 people still alive 60 days after the bacterial infection infected the public. How many people were there in the beginning? So we know this is 60 days in, or 60 days in. So we don't know the original amount, your principal. So I'll put a P here. We know that it is decreasing by 12%, so that's 0.12, and that 60 days have passed. So at this point, we have 116,654 equals P times 0.88, 0.88 to the 60th. So when you plug this into the calculator, which you guys won't have to do, so I'm just going to give you guys the answer. It would be that in the beginning, there were 249,999,595.6 people. And because there's not a 0.6 people, we would round that up to include that partial person as a whole person.